Welcome everybody to AG Maths, The Way of Life. This is my email address ajaymisra.49@gmail.com. In case you need to reach me with your comments or with your observations, with your queries, you can reach me through this or put in the comment box. Today we will be talking about relations and functions. Why I have picked up this topic? Because without functions, we cannot enter the branch of mathematics called calculus. Calculus is very important for higher studies of science, technology, or engineering. In case you want to learn something on computers, which is the future of our present age, that we cannot do without computers, our work of life has become computerized. The functions is the gateway to that subject. And to understand function, we must know relations. I hope everybody is already covered the relation part. So just to introduce what is relation and how in practical everyday life or real life this relation function plays this role. Talking about relation, we live in a society, we live in a family, and in family there are many members, and each member is related to each other, and that is what is a physical relation or social relation in our community, in our family. Brother, sister, mother, husband, wife, all these are called the relations. And similarly, in mathematics, the numbers have got their relation, or alphabets have got relation, has been developed to further understand the subjects. So, relation can exist only between two things. It cannot happen in to one thing. One object has to get related to other one. Like if I say some numbers, it's a Cartesian pair of some numbers, 1, 2, the relation, then I write 2, 4, 2, 5, 3, 6. It's a set. Set is denoted by a curly bracket, and these are called the ordered pairs. Ordered pair means there will be a number appearing first position and then a second position. First position number is always called the domain, the x value, and the second position is called the y value. We have learned it in our earlier days in coordinate geometry as well as in our relations. So this is first element and second element, first, second like this. So it is a ordered pair. This is called a relation. I give you another example for relation. It is 1 3, 1 5, and 2 7. This is a relation. That means we have a set of domain related to a set of range. So I represent the domain like a cloud, a part of cloud, and a range by another part of cloud. So it is called the domain, and this is called the range. Here in domains, I will put all the first element of the relation number 1. So it is 1, 2, 2 is repeated, and 3. So corresponding range values are 2, 4, 5, and 6. So 2, 4, 5, and 6 are here. So we can see that 1 is related to 2, 2 is related to 4, 2 is again related to 5. I put arrow to make you understand that how the relation is taking place. And 3 is related to 6. So relation goes from domain to range. Here you see one very special thing, that each element on the domain has got one range connection, but only one element in domain number 2 is related to two of the range values. In such situation, we say that one object can have two images. This is also called pre-image. In some book you'll find it is pre-image, and this is called the image. One object can have, or one pre-image can have two images. The physical understanding for this idea is, if I take a very thick mirror and I put my fingertip onto the mirror, you'll find it will have one shadow, one image. Behind that there will be another image, and followed by few more, and the images will get little uh, uh, shadow and shallow. The first image is the very prominent one. Next one is little less prominent, and likewise. So one object can have physically also more than one images. So this is what is reflected in this relation. Second one, you see, one is related to 3. Now one is related to 3. I draw another set like here. I'm drawing some irregular shape, that means a cloud which can accommodate so many number of members. So 1 is here and 2 is here. So 1 is connected to 3, also connected to 5, and 2 is only connected to 7. So this is how a relation is defined. Right, there will be different types of relation that we are not going in detail for that. So now there is a difference between this relation and function. If I tell you what is a function, first I give you the example, then I tell you what is the definition of the function. 2 1, 5 1, and 8 1, 7 2, and 4 3. You have understood. I'll clean this part of the figure. Just remain. Okay. Now this is one example for function. What is source? We have again the Cartesian order set 2, 5, 8, 7, 4. These are all here. So writing in chronological order, ascending order 2, 4, 5, 7, 8. Then we have image here, or the range, which is 1, 1, 1, 2, 3. It is on 2 and 3. Now see the how these order pairs are made. 2 is connected to 1, 5 is connected to 1, it goes like this, 8 is connected to 1, 7 is with 2, and 4 is with 3. Here you'll see the difference. This is called domain, and this is called the range. Or you can also say pre-image and image. Here, more than one domain can have only one image. Similarly, can also have one-to-one also. So more than one pre-image will have one image. That means if in physics you have remembered, we can have 1, 2, or 3 objects standing in a line, and if I look at the screen right from here, if my eyesight is here, and I look at the tip of each arrow, then all the 3 arrows will combine into one, and in the lens or in the mirror I'll get one image. So 3 objects, one behind the other, can completely overlap each other symmetrically, then it can form one image. So that is the concept. You can understand physical interpretation is 3 objects or 3 domains can form one image. That is called a function. But Here, the objects are all different. So this was the example for function and relation. But why we will study function? Tell me. What is the practical application of function in our life? I tell you, day-to-day life, whatever developments of science and technology has taken place, we cannot do away without the utilization of function in our way of life. Look at your mobile smartphone. This smartphone is locked by a particular number. Every smartphone has got a particular number to lock and unlock. Without putting those numbers, you cannot unlock the phone and it will not work. So for functioning of an equipment, we require some input, right? And that will give me an output. Similarly, when you look at the TV, you want to work and see a news channel or a sports channel, then you have to click your remote. Remote is in your hand and TV is on the wall at a far distance. So you put some numbers on the remote to get the particular channel for operation. Likewise, we have computers and laptops where you want to go to a particular site or a web page, you need to click certain keyboard, keyboard knobs. Then only you get to see those things on your screen. So this is all due to a function. And function is nothing but machinery which requires an input to give you an output. Every time you have seen an input and an output. Another very simple example is if you want to light a room, you need to go and operate the switch. If you operate the switch of a fan, light will not work. And if you operate the switch of a light, fan will not work. So individually, you require one-to-one relation between a switch and a fan and a switch and a light. So this is what is the physical application in our day-to-day life for a function. That we need to have an input and then we get an output. So to tell you in brief what is a function, I write here how the function is operating in mathematics. If we have a imaginary box here, which may be called a box of function. Functions are denoted by f of x. It is not multiplication of f and x. It is function denoted by f of x. We need to have an input and that input can be suppose x and we write it here as input. And then I get an output. Output is nothing but f of x. This f of x sometimes we also say as y. Now this x is called the independent variable, independent, and here what we get is dependent. So independent variable, when it is put into a box, we get a dependent variable depending on the value of x. Suppose we get here as 2x plus 3. This is what is my fx. When I put x here, I am getting 2x plus 3. So this was your input and this is your output. What happened? This x was turned around in this side machine and that x got multiplied with a 2, a scalar number, and addition of 3 to get me a final value of 2x plus 3. Now, for every x value, we will have a different y value. So I make a chart here for a x and a fx. If I put x is equal to minus 2, minus 1, 0, 1 and 2, I'll get different values for fx, which we know how to do. Minus 2 if I put here, it will be 2 into minus 2 plus 3, which gives me minus 1. Minus 1 if I put here, it is 2 into minus 1 plus 3, which gives me a positive 1. 0 will give me a value of 3 only. When I put 1, 2 into 1 plus 3 will give me 5, and 2 into 2 plus 3 will give me 7. Now if I plot a curve, what it will look like? Suppose this is your x-axis and this is my y-axis. So y values are from minus 1 to 7. Suppose here it is minus 1, plus 1, 2, 3, 4, and 5, 6, and 7 somewhere here. Right. Now, for x value of minus 2, y value is minus 1. So x I will have to plot here. Minus 2 is here. Then plus 1 plus 2 is here. So for minus 2 it is minus 1. Minus 1 is here. So the point will come here. Minus 2 minus 1 point is this one. Minus 1 and 1. This is called minus 1. This is 0. So this is minus 1. This is minus 2. For minus 1 it is 1. So it goes up here. At 0 it is 3. When x is 0, 1, 2, 3. The value is here. Similarly for 1 it is 5. As coming positive 1, 3, 4, 5. So the value may be somewhere here. And for 2 it is 7. When it is 2, maybe 7 is here. So when you join, I get a straight line. Roughly I am drawing it. This is not as put to the scale. So you get something like this. So this is called a linear output or linear equation, because we got a line. Functions can be linear. It can also be polynomial, maybe having some powers, maybe trigonometrical function, maybe geometrical functions, like that. So what are the types of functions? I'll talk something about that. I hope you are understanding. In case you have any doubts or any questions, you can reach me through the comment box, or you can put your message in the email, which I'll try to answer to the best of my ability, and hope that will be beneficial to you. Now we have, I'll show you a few graphs so that we can understand what are the types of function. Or first of all, let me tell you, it is identity function. First one. Second is your constant function. Third is polynomial. Then comes your rational. Then modulus function. Signum function. And greatest integer function. These are the functions which normally we are required to study in our syllabus. Identity function is what? If your x is equal to fx, that means we can say x is equal to y, because f of x function is also called y. If x is equal to y, it becomes identity function, and the graph for that will look like something, a line passing through the origin with a 45-degree angle. Why it is like this? Because for any value of x, y value is also same, like here. See, for each value of x, y value is same. So this was your identity function. What is the constant function? If I have an axis here, x and y axes, and we have fx is equal to constant. Say c, that means y value is constant. for any value of x. So I will put here as a C, and it is same throughout. For any value of x, the line goes like this. So this is a constant function. What is the polynomial? Polynomial function can be other than a linear function. Suppose I draw a polynomial function as fx is equal to x cube. If this is a function, then it will look like S form. This is a polynomial function. Fx is equal to x cube. It can also be a quadratic function. This is fx equal to x cube. When x is negative, it goes more and more y value. Minus 2 into minus 2 into minus 2 is minus 8. So for minus 2 here, the y value will be more than that, 3 times, or maybe more than that, 4 times. So likewise, if it is positive, it is 3, then 3 into 3 into 3 is 27. So one value at 3, y value will be 27 something. So it is that polynomial function. Another polynomial, for example, we can draw a parabola, or fx is equal to x square. What is that? It will look like this. This is your x axis, this is y axis, this is origin. X is positive 1, y is also positive 1. So it is 1 to 1, like this. F is negative 1, it becomes positive. So y is positive, even on the negative side of the x-axis. F is negative, x is negative 5, so it will be somewhere here, negative 5, but y value will be positive. If x is positive 5, it will be positive. So it will go like up. So it's a top opening parabola, fx is equal to x square. So that is polynomial form of function. Rational function are normally called fx is equal to say x 5 by x cube, or multiplication or additions. Now modulus function is defined like this. For this, we know that these are all positive values. X will be all positive. So the graph will look like the mirror image of the left side onto the right side. Signum function. What is the signum function? Signum function is, it will have, say, fx is equal to x when x is greater than 0, is equal to 0 when x is equal to 0, and minus x when x is less than 0. When different conditions for x, the value of fx is varying. So when the value of fx is varying, we can plot a graph accordingly, and that will be called a signum function. Now, what is the greatest integer function? Greatest integer function is when I write the function fx is equal to 3.5. The greatest integer here, closer to the number, is what? 3. 3 is the whole number which is greatest possible in this figure. Greatest is 3. And if I write, or fx is equal to minus 1.2, what will be the greatest value for this? When you look at the number line 0, minus 1, minus 2, minus 1.2 is coming here. So the value minus 1 is the greatest value here, because minus 1.2 is smaller than minus 1. So the value for the greatest integer is minus 1 here. So likewise, we get the values for x and y to be plotted. So this was about the different types of functions what we can discuss. Right. So I have taken enough time. So we'll talk furthermore in our next class. Thank you very much. Please watch, and if you like this video, click on to the icon and subscribe in order to get future references of my next videos. Thank you so much.